Hello, this is Bernard Lijický, your professor for Data Science 201, and this is the first recording. We will be going through some little examples of what we will do in the class over the course of the semester. So this is just a quick introduction where you will see all of the data science, or most of it, the fun part that we will do. The course has been developed over many years. Originally, when I started teaching this course 4 years ago, I got some head start with a course that was developed by Adisak Sukul from Computer Science and Man Basnet from the Department of Mathematics. Then we worked on it with Jennifer Newman and also Klaus Kadelka. So it's iteration of many different people who worked on it. There are two sections in this spring. One is in person and the other one is online. We are in the online section, as you can see. There are two TAs that are from mathematics, same department as me, and there will also be help for TAs that are in the in-person section from the computer science. The two sections, the in-person and online, are very similar, which means that you'll have the same homework assignments, same labs, and you will have to do the final project that is, I would say, main part of the course, where you will somehow put everything that you learn here together. Right. But there will be some differences, such that the exam will be administered differently. There will be quizzes in Canvas for you, and there will be no attendance in a way. So let's try to do a first example. So here is the example where you have some data. You have a bunch of students. You have students 1, 2, 3, 4, 5, and for each of them you know how many hours they studied for the exam. Right? It goes from 2.5 to 8.5, and then we also know what score they received on the exam later. Right? The ranges from 21 to 75, and now question is, if you have a student that studies 4 hours for the exam, what would be the score that one expects to get? If you can study for 4 hours, what do you think will be your score? Right? Or another version of the question, what do you think will be the score if you study 10 hours? Or what is the score when you study 40 hours? And these are questions where you are trying to somewhat predict what will happen in the future. Right? You don't know what will actually happen if you study 4 hours, but it's what you are trying to guess. Right? And what you have some data that are numerical data, and you are trying to predict something that is also numerical value. The first thing that we will learn in the class, or we'll do with the data after we clean it, we try to visualize it. Okay? If you look at the previous slide, you see the table where you have 2 columns and different numbers to it. People are much better at looking at pictures than looking at a bunch of numbers. Right? So here is the visualization of the table from the previous slide, and you can kind of see that here the number of study hours as it increases. So here is the number of study hours on the x-axis, and as it increases, the mark on the exam is also increasing. That's one would expect, right? And from this you can kind of guess that if you study 4 hours, you will get somehow like 30, between 30 and 40%. If you study for 10 hours, it would be somewhere here, right? So I don't know, it's not really there, maybe around 90% points, right? So what it looks like is that one could put a line here, and if you put a line through the points, that will somehow give you the relationship between the number of hours you studied and the grade you get in the exam. So here I put the line in between. Right? This is called linear regression. We'll try to learn later how to do it if you have more than two axes, and sometimes one can plot in not just a line but some different curve that fits the data. And here linear regression does the thing pretty nicely. So here you can see even better. Now 4 hours will give you maybe 38, and 10 hours it is off the chart. Okay? But if you try to calculate it, you can calculate it as a linear function here, and then you plug into the linear function. One thing that this example also illustrates is that if you study 40 hours, then this line will get above 100 on the student grade. Right? So the relationship between the number of hours you study and the grade you get is not actually linear. There is some other constraint such that there may be a cap of 100% to get from the exam. Right? And it's not obvious from the data itself. So sometimes one has to be a little bit careful, and if you use these predictions, if you predict something that is way outside of the data you have, you may get something that is not quite correct. Okay. A different example of predictions will be a decision tree. Okay? So here is a problem. We have different animals: salmon, bat, whale, porcupine, cat, a bunch of different animals. And for some of them, we can say they are mammals, and for some of them, we have that they are not mammals. And for each animal, so this is the thing that we will be interested in. Mammal yes, mammal no. And for each animal, we have some characteristics. Right? So we know if it is warm-blooded, cold-blooded, if it gives live birth, if it has 4 legs, and if it hibernates. Okay? So you observe for each of these animals different features. In this case, they are all binary, yes, no. But you could possibly also have numerical values if you really want it. Okay? And what I would like to do is, if you give me animal where you say if it is warm-blooded, if it gives live birth, if it has 4 legs, and if it hibernates, then based on these 4 characteristics, it will, as an output, decide if it is a mammal or not. Okay? And the thing, the algorithm kind of is a decision tree. Here is an example of a possible decision tree. Okay? So if you get me some animal, I will first look if it has 4 legs and answer the question yes or no. And if it doesn't have 4 legs, if the answer is no, then I will continue to the left box here. If it has 4 legs, then I will continue to the right. And then I will ask if it hibernates, whether no, then I go to mammal, and if yes, then I will say it is not a mammal. Right. This is an example of what I would like to create. Right? It is not quite correct, right? Because you can find some animal over here where if you try to plug it in this decision tree, then it will not answer correctly. For example, if I look at the whale, and I say whale, does it have 4 legs? 4 legs, no. And my algorithm says it is not a mammal, but it's not correct, it is a mammal. Right? So this one is not correct. I just wanted to show you what one would like to get. Right? So if you are brave enough, you can try to make one yourself, right? Because you learn best if you try to practice. If you practice yourself, you learn best. So here I try to show you what I would like you to get, and I showed you that what I have here is not quite correct, right? Right. And here is a better thing, right? Now this thing should be correct if I didn't mess it up too much, right? So here, if you take any of these animals and throw it in, then it will decide whether it is a mammal or not, right? Let's try here, salmon, mammal, no, so we should get not a mammal eventually. So let's see, blood, cold, not a mammal, right? So it classifies salmon as not a mammal correctly, right? How about cat, blood, worm, okay, so it goes this way to the live birth. Does cat give live birth? Yes. And our decision tree announces cat is a mammal, and cat indeed is a mammal. Okay? So this is an example of a decision tree. It is not a unique one for these animals. Right? You can have a different one. So if you came up with a different one, it is possibly correct. Right? It's not that this is the only possible correct one. Right. The real test now is if you have data that were not in the original set that you used to construct the tree, and see if it works on the new data, right? So the dog was not included in the previous set of animals. So let's see if the decision tree works on the dog. So dog, blood, worm, yes, live birth, yes. So it is a mammal, and dog is indeed a mammal. So here our decision tree correctly classified a dog that it didn't see before in the training data. Right? So here we can try to be happy and say, oh, our decision tree works great for some data that it has not seen before. Right. There are also other animals that maybe were not included in the testing data and are not as great for our decision tree. So here is platypus. Right? So let's see. Platypus, blood is worm. Does it give live births? No. No. So our decision tree is saying platypus is not a mammal, but platypus is a mammal. Right? It's a kind of not a typical mammal, but it is. So in this case, our decision tree failed to correctly classify platypus. But all the data that we had for training, decision tree worked well. But there are some corner cases where it may not work as we were hoping. Right? But this is something like for future for you to remember that sometimes, even if your model works perfectly on the data you have, there may be some things in real life that it doesn't capture. Right. So here is a little bit of the course, what we are trying to do here, or what we will be doing in the course. Right? Right. So one of the things is that if you have just few entries like we had, you can do things by hand. If you have more entries, more data, then you cannot do things by hand, and you'll need some machine to help you with it. So we will try to learn how to explore data sets that are a little bit too big to do by hand, and how to display them, how to make some visualization. If you manage to display your data nicely, it can reveal some hidden connections, and life becomes much better. Right? The main thing that we will try to do, or our goal eventually, is try to do some models that will predict some numerical values, which will typically be linear regression, or that will do some classification, which will be decision trees. But we will try to do it with sets that are too big to do by hand, but not too big that you need some big database to store them, right? And then we will try to discuss a few other things. For example, how do you check if the model that you create is reasonable? By that I mean, if you look back, we had this decision tree where we had the platypus, right? So what we will do is that we will have the data, we collect all the data that we can, and then part of it we use to create the model, and when we have the model, we'll use data that were not used to train the model to see how well the model performs. Okay. Right. We will use a bunch of libraries in the course. So what we will do is we will use Python as a programming language because it's relatively accessible and there are many tools that work with Python. So the tools that we work with Python, so the libraries that we will use are pandas. Pandas is a library for manipulating tables. You can think of it as a table in Excel in some sense. Then we will use matplotlib, which is a library that is very good for drawing diagrams or displaying data, plotting charts. And then we use scikit-learn, which is a library that will create linear regressions and decision trees for us. Right, so here is some quick outline of the course, how it will go. Right? First, we will do some data in Excel. One would think that we will do the programming thing, that will be more fun. But if you have a project that is small, if it's really just few things that you need to do, then Excel is a great tool. Right? So if all you need to do is draw a few pictures from the data through your diagrams and do some basic statistics on the data, then Excel will do great. So we'll spend 1 week on the Excel. Then we will need to learn a little bit of Python. There'll be about 2 weeks of introduction to Python. So it will be kind of tricky. We don't expect any knowledge of Python when you take the course, so we'll have to give you some at the beginning, otherwise you will have no chance to do anything else. So if you're already proficient in Python, there'll be 2 weeks that will be kind of boring. And if you are new to Python, there'll be 2 weeks that will be fairly quick for you, and it will be a little bit well, you'll see a lot of new things fairly quickly. The good thing is that we do not need too much special things from Python. So as long as we understand a little bit of the syntax, it will be okay. So all the theoretical things that we will look at are already implemented in one of the libraries, so you don't actually have to implement too much. You just need to be able to call different functions that somebody else already wrote. When we are done with the introduction to Python, we will try to do a little bit of data manipulation in Python, which means we will do some introduction to the library pandas. Then we will do some visualization, which is matplotlib. Then we will need to do a little bit of math. We'll need to learn a little bit about probability and cause and effect. Okay? So then you will be able to better understand what different things mean. And then we will do the part where we will try to do decision trees and linear regression. Well, the thing that you saw as a little examples here at the beginning of the section today will be done in more depth, and it will not be done by hand, it will be done with computer. And then we will do a few other models, and we will spend time on your final group project. Technology that you will use in this class. So first, you will need Microsoft Excel. Online version may work, the offline version works for sure. The Excel, we will need it next week, so please try to get it this week if you can. The second piece of technology that we will use is Google Colab. If you go to Colab, research google.com, you can get free access, and what you will see is a Python workbook that you can write comments in, and it will nicely work online. The good thing about this is that you do not need to install anything, so it's fairly easy to start, and all the libraries that you need for the course are already installed there, so it's easy that you don't have to worry about setting up. Okay? If you want, you are welcome to use any other software to do the Python exercises and problems in this course. Okay? But this is what I would recommend if you want to avoid troubles. Okay? The AI is something that will work for this class quite well. And it will work quite well for two reasons. The first one is that there is a lot of examples for data science on the internet, so they are in the training data for the large language models. And second, why it works well is that you can check the output or the correctness of the output. Right? The problem is the large language models that they hallucinate, which is a nicer word for lie or make up things. Right? But if you ask, I would like a Python code to display this type of data, it will give you the Python code, and then you can try to run the Python code, and you'll immediately see if it displayed the data as you asked. And if it does, then hooray, it worked. And if not, then it was hallucinating and you can try again. Right? So in this case, it works well. So you are welcome to try it if you want. I would recommend first try yourself, and then if you fail, you can try to ask the ChatGPT or Gemini or whichever service you like. I will not use it myself during the demonstrations. I tried it in the past, and the feedback from the students was that they didn't like me doing it. So I will not do it, but you are welcome to do it for your labs or homeworks. I should give you a warning that if you use it, you should know what is meaning of the things that it produces, right? Especially if you do it for, let's say, the final project, and it creates something that you don't understand, we may get into awkward situations. Okay, so course format. So how will the course look like? There will be online lectures like this one that I will be posting on Canvas. There will be labs. Labs will work following way. There will be Python worksheet usually, and that you have to answer several questions. And in order to help you with it, there will be a recording posted on Canvas that will go through most of the lab. So it will go through and explain what is being done and how to answer the questions. It will not do everything. There will be portions occasionally at the labs where you will have to show your own work. There'll be quizzes on Canvas. There'll be homework assignments. Homework assignments will be due on Tuesday. Homework assignment will be very similar format like a lab, but it will not have any video that will tell you how to do it. There will be 2 exams in the testing center, and there will be a final project. Finally, I hope that you will spend some time looking through Canvas. You can find slides from the presentations on the Canvas and other class materials that I will be using. In the Canvas you will also see all your assignments, which includes the quizzes, labs, homework, final project. This class does not have a textbook that you need to purchase. There are some reading materials which are online books that are freely available, links through Canvas, so please take a look. Our goal in this class is that you see what the technology can do and some basic ideas how it can be applied. We are not trying to make you memorize all the functions in every module. We are trying to make sure that you know basically how the thing works, and if you need, you can go and explore.